Good morning. In this video session, I would like to discuss about kinematics of rigid body. Now, the particle is different from the rigid body. The dimensions of the body, if they are negligible, it is called a particle. If you consider dimensions of a body, then it is called rigid body. Now, a rigid body kinematics. In the kinematics, you are not bothered about the cause of motion. You are not bothered about the cause of motion. So consider a pendulum like this. This hinged over here. Now, this pendulum is having some length, say 2 meters, and it is having some weight, W. Now, this pendulum is moving to and fro. The pendulum is moving to and fro. Now, at this particular point, it is having maximum velocity because with the help of the velocity, it has to move to this particular location. Here the velocity is going to become to 0 and it is coming back from here, and the velocities keep on increasing and becoming maximum, and with this velocity it is going in this side and it is having maximum velocity here. So the velocity at the two locations, that means swinging over angle of theta, here it is having a 0 velocity and the maximum velocity is here. Now, what is acceleration? Here velocity is defining like this. What is acceleration? The acceleration is, so if you draw a curve between time and theta and velocity. So maximum velocity to the minimum velocity to the maximum velocity. This is velocity. That means at t is equal to 0, theta is equal to 0, it is having maximum velocity. At theta is equal to some value, say some 30 degrees or 40 degrees, whatever it is, depending upon the swing which we will do, it is having 0 velocity, and from this angle to other side, it is having negative velocity. So it is like this. So the velocity is equal to omega into r. That means this is omega is the angular velocity, r is the radius. And this is the maximum velocity, Vmax. Now, what is the angular acceleration? What is the acceleration here? This is having two types of acceleration: alpha into Alpha is the angular acceleration. Okay, it's having angular acceleration alpha. Now, angular acceleration is nothing but d omega by dt. At theta is equal to 0, v is equal to omega r. At theta is equal to say T max, T1, v is equal to 0. And theta is equal to 0, v is equal to omega r. At theta is equal to minus theta 1, v is equal to 0. So, the acceleration diagram will be like this. This is acceleration diagram. At theta is equal to 0, the acceleration is, that means the acceleration, the direction of acceleration is changing. Here you have maximum acceleration, here you have zero acceleration, and here you have a maximum acceleration. So this is a rigid body, and this is all kinematics. What is the kinematics? Displacement, angular velocity, and angular acceleration. Similarly, if you see this railway IC engines, the steam engines, there is a cylinder, and you have a piston over here, and this piston will be connected to a connecting rod, and this connecting rod will be connected to a crank. Now, this crank is rotating with omega in anti-clockwise direction. This piston is moving to and fro. Now, the problem of kinematics is because it does have uniform angular velocity, the angular acceleration of this crank is 0, alpha is equal to 0. But this connecting rod will be having angular velocity and angular acceleration, angular velocity and angular acceleration from theta is equal to 0 to theta is equal to 360. That means this crank is rotating in 360 degrees. So this is theta and this is omega connecting rod, the angular velocity of connecting rod. And similarly, this is theta, 0 to 360 degrees. This is the crank is having radial and normal acceleration, radial acceleration and normal acceleration, alpha and omega square r, omega square r. Similarly, the piston is also having linear velocity and linear acceleration. Linear velocity and acceleration. That means when piston is at one extreme end, the velocity is equal to 0, the acceleration is maximum. And the other end, so here at some point the velocity will be maximum. and at the end velocity is equal to 0 and acceleration will be maximum. Here acceleration will be 0. So the kinematics of rigid body, here you are not talking about any mass of the bodies. It is a rigid body because it has some dimensions. The crank will be having some dimensions, and connecting rod will be having some dimensions. Piston is having some physical dimension, and the cylinder is having some dimensions. So it is a rigid body, and the cause of motion. Why this motion is being imparted to these particular links, that is not bothered. So in the kinematic of rigid body, we are trying to find out the displacement diagram, velocity diagram, and acceleration diagram. So this is what I can say about kinematics of rigid body. Now, what are the problems of this kinematics of rigid bodies? So the rigid bodies can be of different types. It can be a mechanism or a 4-bar mechanism, like so if you see several machinery, there are different types of linkages and they're all considered as mechanisms. So a 4-bar mechanism and slider crank mechanism, double slider mechanism, and other different types of mechanisms are there. These mechanisms will be having some dimensions, and some velocity will be given as an input to one particular link, and how these other links are moved with the angular velocity and angular angulations. This all will be calculating in this particular kinematics of mechanisms. So once you complete the exercise of kinematics of mechanisms, problems. Now each problem can be solved within, say, some 40 minutes or something like that. So we can plan of taking some 15 to 20 mechanisms, and each mechanism we can clearly understand how the kinematics problems can be solved. So even in the examinations, government examination, UPS examinations, you'll be given a 4-bar mechanisms of different dimensions, and you'll be asked to draw the velocity diagram and acceleration diagram. So it will take some 30 to 40 minutes. So you have to do precise in the correct manner. So this is the exercise that we can leave in this kinematics of rigid body. So once you complete this particular exercise, the next thing is the kinetic part. What is the inertia force? What is the force diagram? And all these things that will be coming in the kinetics of rigid body. So this is what I would like to discuss in this small video session about the kinematics of rigid body. Thank you for watching the video.